night, good morning, or good afternoon, depending on what period you got me. Today, I do that all the time. Section 1.3 is midpoint and distance. So we're kind of going at a section every day kind of pace, but understand once we get through the chapter, we will go back and kind of redo each of the sections again, just to kind of review. I don't like necessarily spending a couple days on each section and then just reviewing like one day before we take a test, because then the first section, it's been a really long time. So I tend to kind of go through the chapter and then go through it again, sometimes one section each day, sometimes two sections in a day. It just depends. So we'll go a little bit faster the second time through, but I feel like students tend to do better when I do it that way versus doing it all at the beginning and then moving forward. So, all right, so yesterday we talked about this word between. It just meant somewhere in there. Okay, today, midpoint does mean like the middle. So we use a lot of pictures in geometry. It's not necessarily a perfectly straight line, but that's okay. If you were told that M is a midpoint, can't spell. M is a midpoint. Okay, then what we're saying is that from A to M is congruent. Okay, so that means congruent. So that symbol there means congruent. So notice, like right now, like if I asked you, well, how far is it from A to M? You could not answer that because you don't have a number in the problem. So we tend to use the word congruent when we don't have a number. And I do need to get in the habit of, when we say congruent, of putting the segment marks there. Because we're just saying, like, well, however far it is from A to M, it's going to be the same from M to B. It could be both 5, it could be both 12, I don't know. So we say that the segments are congruent. And we indicate that on the picture by putting like a slash mark in between there. So if you didn't have that M as a midpoint and you just had, like all this wasn't there, you just had that picture, you could say M is a midpoint because you know that from A to M is congruent from M to B. Okay? So midpoint means right in the middle, midpoint. All right, we have another word that we'll use a lot at different times, bisect. Let me erase that. Bisect and midpoint kind of go hand in hand. There's a formal definition in the book, but what I want you to remember when you see the word bisect or something is a bisector, cuts in half. One of these days I'm going to get better at writing. Cuts in half. So something was 12, it gets cut in half, it's 6 and 6. Okay, so going back to this top like picture, if I said M bisects AB, then it cuts it in half. That means that if you cut something in half, that both parts are equal. So if I said M bisects, you could conclude that M is a midpoint. If I told you that M is a midpoint, you could conclude that M bisects AB. So you could have a point like that picture above us as a bisector. You could, well, usually it's just a segment, it's not a line, so let me take away those arrows. So if you had A here, B here, and you had some line, that's pretty crooked right there. You had a line go through there. It's not perfect, but it's okay. And let's say that we labeled this line D. And it said that line D is a bisector. Then you could conclude, it cuts it in half, that AC is congruent to CB. Or you could mark it like that. They could go the other way, doesn't matter. Just as long as there's one little slash mark, you could actually even have two, they just have to match. Okay, so if you see a picture and it has those little red like slash marks, you automatically conclude they're equal. Okay, so if one side's 2, then the other side's 2. If one side's 6, the other side's 6. Okay, so you'll have some problems that deal with like both of these terms. So let's look at something that you might see, and you got to be careful of the directions and what it's asking for. So let's say I had, I want that to be -1, not +1. This problem, and it said that point C is a midpoint. And it wants me to find sorry about that, kind of lost it there, but point C is a midpoint, find the length of AB. Alright, so if C is a midpoint, I know that, it's not the greatest, but well, let me write it differently. I know that AC is congruent to CB. And so yesterday when I talked about this word congruent, I said sometimes we say it's equal. So how could I use algebra now? Like okay, big deal. They're congruent. Remember I said sometimes you can say they're equal. Well, if they're equal, wouldn't 4x minus 1 equal 3x plus 3? And I can solve that. Add 1. Subtract 3x. And the most common mistake on a problem like this, oh, x equals 4, I'm done. No, you're not. Go back and read what it said. Find the length of AB. It didn't say solve for x. It wants to know how far is it from A to B. So I got to plug it in. And you could plug it into the whole thing, but I like to be what I call constructively lazy. Well, I have 4x minus 1. If I plug in 4, 16 minus 1 is 15. Well, that means from A to C is 15, and so is it from C to B is also 15. So I could just say AB equals 30. So if you wanted to plug it back into both of them, you could get the right answer, but you don't need to. Okay? So you're going to have some problems that have just some regular numbers. Oh, the right side is 12, so the left side is also 12. And then you will have some that deal with x's. Okay, but since we're dealing with midpoint, all of them you'll set up as equal. And then make sure you go back and answer the question. It might say solve for x, in which case you would be done. If it said how far is it from A to C, well, A to C is 15. It might say how far is it from C to B. It might say how far is it from A to B. Go back and answer the question. Okay. So then we're going to move on to finding midpoint. And I like to think of it a little bit, not a little, I guess it's the same, it's just in a different way. There is a formula for midpoint. And, excuse me, it's can be cumbersome. Depending on how you view stuff, but x1 plus x2 over 2, comma, y1 plus y2 over 2. So add the x's together, divide by 2, add the y's together, divide by 2. I like to think of it like that. Yeah, there's this formula, but I think sometimes it's easier if we add x's, divide by 2, add y's, divide by 2. Versus trying to use this whole formula thing. Okay? So if I had 2 comma 6 and 4 comma 11. Find the midpoint. Well, you see you plug it in the formula. This one isn't terrible because I use all positives. But add the x's, divide by 2. Okay, 2 plus 4 equals 6. Divided by 2 is 3. Add the y's together. 6 plus 11, 17. Divided by 2. So if you wanted, you can divide that. It's a decimal. So you could leave it as 17 over 2. There's nothing wrong with that. Okay, or you could put 8.5. It's 8.5. Either one is fine. But the answer, it says find the midpoint. So the answer is not 3 and 8.5 or 3 and 17 over 2. You need to write it as a coordinate. Either like that or like that. I don't have any strong feelings one way or the other. I think 8.5, since if I had to lean one way, I'd probably go with this one because we're looking at like a point on a graph, really. And if I said where's 8.5 on a graph, you could go there. If I said where's 17 over 2 on the graph, you'd have to figure out that it's 8.5 or 8.5 anyway. So, but in terms of if it said find the midpoint and you put 3 and 17 over 2, correct answer, you're good. Okay? So you have some problems, find the midpoint. Yes, there will be some negatives. So, then you'll have some problems that are there's given an endpoint and a midpoint. Okay, so you're gonna find the other endpoint. And I'm going to show you a way that I think is significantly easier to do, but it's not in the book. So any of the examples you see in the book are going to use the midpoint formula, and it's this big old long algebra problem when I don't think you need to really do that. So let's say we had an endpoint that was -4, 7, and we had a midpoint that was 0, -3. And the question is going to be, what's the other endpoint? So if you, like a visual of this would be, on like a line. Here's our endpoint, and here's our midpoint, and like, what's this one over here? So here's the way that I think of this. Midpoint means in the middle. Midpoint means if this distance was 10, I'd have to go 10 more to get to that other side. If this distance was 8, I had to go 8 more. It's right in the middle. So if I took 10 steps to get to the middle, I'd have to take 10 more steps to get to the other side. Okay? However you want to, like, if I drove 10 miles and I'm right in the middle, I'm halfway there, I have to drive 10 more miles. So this is the way that I think of it. I'm at the endpoint, -4 to 0. How much does it change from, think of a number line, from -4 to 0? Okay, it changes 4. Does it go up 4 or down 4? Well, it goes up 4. Is it -4 plus 4 is 0? So go 4 more. What's 0 plus 4? 4. So the x part of the other endpoint is going to be +4. Then do the same thing with the y part. How far, like from 7 to -3, how far does that change on a number line? Well, some of you may have already got it, and that's fine. But if I go from 7 to 0, well, that changed 7. But I need to go all the way to -3. Well, from 0 to -3 is 3, so it changed 10. But it went down 10, so I subtract 10. And I get -14. And that is the other endpoint. Okay, you're welcome to look in the book. It's going to show you a very lengthy, possibly confusing algebra problem. So I definitely would recommend just doing the how much does it change. Okay, how much does it change just the x numbers? How much does it change just the y numbers? And then do that again. Just like if you drove 10 miles, you drive 10 more miles. You walked 10 feet, walk 10 more feet. Do the same thing. Okay, so I didn't write this, but 7 minus 10 is -3. -3 minus 10, -14. You just keep going. Okay, so kind of a lot of different versions of the problem. So, but you'll have some where it just says find the midpoint, and then some that it'll say you have an endpoint and a midpoint, find the other endpoint. Okay, all right, one more thing to go. Distance. So we have a distance formula. Okay, and I tend to do the problem a little different, but the distance formula is not bad. This one I kind of can go either like direction on. Okay, so the distance formula is this big giant square root. And we are going to subtract the x's squared. We're going to add, subtract the y. Oops. It looked a little bit too much like an x squared. So you can take your numbers and plug them in to that problem. Or you can do this. So if I had negative 5, comma 4, and I had 2, comma 6. So this would be like x1, y1, the x part of the first point, y part of the first point, x2, y2, plug them in and work it out. And if you do that, that's totally fine. The other version, and they really do go together, is if I put negative 5, positive 4, and then I put 2, 4, 5, 6 on a graph, it's asking me how long is that line, or that segment. So I could create a triangle, and I could do Pythagorean Theorem, a squared plus b squared equals c squared. And so here I'm just going to count, really, and then plug it in. So the red line, if I count over from the point, I would go 1, 2, 3, 4, 5, 6, 7. And then for the blue one, I would go up to, so 49 plus 4 equals 53. But it's not 53, because remember what we just found was c squared equals 53, and I just want c. So c is the square root of 53, so there's your big square root up there. Or if I said, well, how long is it? It's the square root of 53. Like, I wouldn't. If you said, hey, it's the square root of 53 is the length, I go, I don't know how long that is, and I'd have to try to figure it out. So what I would look at is say, well, I know that the square root of 49 is 7. It's close to 53. But it's under 53. So then I would go up higher, and I would say the square root of 64 is 8. And then I would just estimate. So I would say, well, 49 is a lot closer to 53 than 64 is. So I would say it's maybe like 7.2, 7.3. And as long as you're close, we're good. Okay? So, yeah, so positives and negatives here. Well, you've done Pythagorean Theorem a ton. So, a squared plus b squared equals c squared shouldn't be something that's brand new to you. So you're familiar with that. So that's a positive. A negative is you got to draw a graph and then a triangle to figure this out. What if I draw the triangle wrong? What if I put a point in the wrong spot? I did one earlier, yesterday, where I did the wrong point on accident, and then I kind of caught myself. But what if you do that? Then you do the rest of the problem. No matter what, you're wrong. So positive, you know how to do Pythagorean Theorem. Negative, you got to draw a graph, and you could make a small error. Distance formula, you got to memorize a formula. That's a negative. And maybe you already know it, but most people don't. The positive, you plug in the numbers in and you go. So, and these two things go together. Pythagorean theorem. Theorems are another rule that we use. We said postulates we used yesterday. Theorems is another rule. The distance formula comes from the Pythagorean theorem. So I'll work it out right here real quick on the side where it's blank, just to show you how it would work out if you did it the other way. But so I have this big giant square root, and it said x2, which is a 2, and here's a mistake that people make all the time. Minus from the formula, and then I have a negative 5. Add, and then I get y2, which is 6 minus 4 squared. So I gotta change this into a plus. And so I get 2 plus 5 squared . 2 plus 5 is 7. 6 minus 4 is 2, and same thing. So I really don't care which way you do it. 100% personal preference for you. Sometimes I think it's easier Pythagorean theorem. Sometimes I think it's easier distance formula. Again, as long as you show your work, I'm not going to mark you wrong if you do one versus the other. Most students, for whatever reason, tend to lean toward the Pythagorean theorem. But again, I don't have an issue with you doing it one way or the other. Up to you. Okay? All right, so a lot of information to kind of go back, on today's. So, you got to go back, make sure you're kind of studying the terminology. We had bisector, means cut in half. Midpoint is exactly in the middle. A bisector could be a point, could be a line. We had the midpoint formula, distance formula. So a lot of stuff to go back and just make sure you remember. Again, for the midpoint formula, you could memorize the formula. It's in the book. It's on the one of the slides here. But I would highly recommend you studying that. How do I find the midpoint? Add the x's, divide by 2, add the y's, divide by 2. That's going to be much, I think, better in the long run. So, and then distance, again, I could go either way. It just really is 100% what you like better. All right, so again, sorry this is a longer one, but go back and study some of those terms after you do the problems, okay? All right, have a great rest of your day. See you tomorrow. Bye.